is, if f is monotonic on closed interval AB, and if alpha is increasing and continuous on closed interval AB, then f is Riemann integrable on closed interval AB. So because f is monotonic on closed interval AB, so without loss of generality, I will be supposing that f is increasing on closed interval AB. And since alpha is continuous on closed interval AB, so if any function is continuous on closed and bounded interval, then that function is uniformly continuous on that interval. So because alpha is uniformly continuous, thus for given epsilon positive, there exists delta positive depending on epsilon only, such that mod of x minus y is strictly less than delta, which implies mod of alpha x minus alpha y is strictly less than epsilon for all xy belonging to closed interval AB. Choose a partition P equal to x0, x1, x2 up to xn of closed interval AB such that delta of xi, this will be less than delta. So we have to choose a partition P in which delta xi is strictly less than delta, right? So we define mi, which is supremum of fx over this closed interval xi minus 1 xi. Now because f is increasing function, and for increasing function, what is the supremum value for this interval? That is f of xi. It is an increasing function. Now small mi will be equal to, it is infimum of fx over xi minus 1 and xi. This interval, which is equal to, now what is the infimum of fx? If f is increasing, it is, yes, f of xi minus 1. Fine. What if the function is decreasing? Then capital Mi will be f of xi minus 1, the opposite. And small mi will be f of xi, right? For decreasing function, this will be opposite. Now since mod of xi minus 1, this is equal to, now because this is always positive, so there is no need of mod, it is already a positive. So xi minus 1, which is equal to delta xi. What is delta xi we have chosen? It is strictly less than delta for this partition, right? So this is strictly less than delta, which means mod of xi minus 1 is strictly less than delta. Applying the definition for the uniformly continuous, whenever the mod of two numbers is strictly less than delta, then therefore alpha of xi minus alpha of xi minus 1, this mode will be less than epsilon. Very good. For all I is equal to 1, 2, 3 up to n, here also you have to write for all I is equal to 1, 2, 3 up to n. Fine? Okay. Now this implies, because alpha is also increasing function, so this is already a positive quantity. So this is alpha of xi minus alpha of xi minus 1. This is strictly less than the epsilon, as because alpha is increasing, so alpha of xi is greater than equal to alpha of xi minus 1, which implies delta of alpha I is less than epsilon for all I is equal to 1, 2, 3 up to n. So I will use this result. Now the last step is, because I need to prove f is Riemann integrable, all steps are over. We have to just calculate UPF alpha minus LPF alpha, which is equal to summation of, yes, what is UPF alpha? It is summation of mi delta alpha I, and LPF alpha is summation of small mi delta alpha I, taking delta alpha I outside. So this is capital Mi minus small mi, taking this outside. Now because delta alpha is less than epsilon, so I'm writing here less than. This is less than epsilon, so this is mi minus mi and the summation, right? So this is equal to, okay, epsilon will be outside, summation I going from 1 to n, mi minus mi. Now what is the value for capital Mi? Because f is increasing function and we have taken the supremum value of xi. See, mi is f of xi and small mi is f of xi minus 1. Let me mark this as star minus, which small mi is f of xi minus 1. If you sum up all this, you will get f of b minus f of a. Rest of the terms will cancel out. And this is just a number. So epsilon into just a number is, again, let me take this as epsilon dash. Fine. So UP of alpha minus LP of alpha is less than epsilon dash. But epsilon dash was arbitrary. We have chosen epsilon to be arbitrary, so this is also arbitrary. So therefore, f is Riemann integrable on closed interval AB. Similarly, we can prove that f is Riemann integrable on closed interval AB if f is decreasing on closed interval AB. All the steps will be same, just you have to change the values for this decreasing function. Hence, f is Riemann integrable on closed interval AB.